Welcome to Module 12, Part 2. In this section, we're going to be looking at the sampling distribution of a sample proportion. So in the previous section, we looked at how the sampling distribution of a sample mean is determined. Now we're going to look at, okay, what if we're looking at a proportion? So the first thing we're going to do is look at how to find a proportion. So the equation to find a proportion is p hat is equal to x over n, where x is the number of individuals with the desired characteristic I can't fit it all. And then n is your sample size. Okay, you can also look at it like a binomial where x is the number of successes and n is your sample size or the number of trials. Okay, so first example, we're going to calculate just the p hat value. So the Harris Poll conducted a survey of 1,200 adult Americans who vacationed during the summer and asked whether they plan to work while on vacation. Of those surveyed, 552 said they plan to work while on vacation. Find the sample proportion of individuals who plan to work while on vacation. So we're going to find p hat, which is the sample proportion. The number of individuals with the desired characteristics, so the number of people that are going to work, is 552. Divided by the total sample size is 1,200. And we get 0.46. And it's as easy as that to calculate a sample proportion. So now we're going to look at what the distribution of all the possible sample proportions look like. So this is found very similarly to how we found the distribution for the sample mean. If we're sampling 1,200 people, we're going to go out and we're going to collect information on every single sample of size 1,200. And we're going to create a distribution from that where we look at the proportion of people that are going to work from each sample. Okay. So now in this case, the sampling distribution of p hat, the distribution that we create by taking all of these samples and finding the proportion of each one, is approximately normal if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Both must be true. So we're going to put an and here. If either of these values, if you do n times p and it's 12, but n times 1 minus p is 9, then it is not normally distributed. Both of these must be true for you to say that you have a normally distributed sampling distribution. Okay? So the mean of our sampling distribution is equal to the population proportion, which is just lowercase p. The standard deviation is the square root of p times 1 minus p divided by n. Notice everything I've done so far is with p, not with p hat. These are p's, this is a p, there are p's in the standard deviation formula, okay? Nothing is involving p hat yet. So we looked at how to calculate p hat up here, but we haven't actually used him yet. We're only going to use p hat when it comes to our z-score. Everything else is using the population proportion p. Okay, and then our z-score equation, I said we were going to use p hat in the z-score equation, and we are. It's going to be p hat minus p divided by that standard deviation, p times 1 minus p divided by n. Okay, I recommend finding that standard deviation first, then going in and using that value in your z-score equation. And I will allow you to use a rounded standard deviation of p when you calculate your z-score. You do not have to use all of the decimals, and we'll see that here in a minute. Okay, so these are the most important formulas for this section. So remember those. That's why they're color-coded. All right, so let's look at an example. The Texas Workforce Commission reported that the state unemployment rate in March 2007 was 4.3%. Describe the sampling distribution of the sample proportion for unemployment with a sample of 117 people. That is, I want you to find the mean of p hat, the standard deviation of p hat, and verify normality. So verify that you have a normal distribution. So we're going to actually do that last one first. So to verify normality, we need to take n times p. So our n is 117, and our p is 0.043. And we need to verify that that value is greater than or equal to 10. And we get 5. So this is not normally distributed. Okay, so we've already run into a problem. And this is a problem that I was going to fix. And I forgot. And I believe, hold on, if I remember what I did last semester. Yes. So to fix this, so we came into this problem and we're like, oh no, our sample size isn't big enough to have a normal distribution. So what do? Well, the only thing you can do, you can't change what p is. You can change your sample size. So I was like, okay, 117 people, that's clearly not enough to have a normal distribution. So instead, we're going to sample 250 people. So if I sample 250 people, okay, so I'm going to cross this out. I'm not going to erase it because it's important. 250 times 0.043 is equal to 10.75, which is greater than or equal to 10. So that's good. So now we got to make sure that n, 250, times 1 minus 0.043 is also greater than or equal to 10. So do that real quick. You get 239.25, which is greater than or equal to 10. So we have a normal distribution, so that's good. So now we need to find the mean of p hat, which if we come back up here, we see that that's equal to p, which stands for the population proportion. So the mean of p hat is going to be equal to 0.043. Notice that I turned that 4.3% into a decimal. You can't do math with percentages. Turn it into a decimal first, then you can go ahead and do math. And then we need to find the standard deviation of p hat, which I had done, but I didn't do it using 250. So we're going to take our p, 0.043, 43, times 1 minus 0.043 divided by 250. And you can type this in your calculator exactly like this so long as you use all of the correct parentheses. Okay, and don't forget that square root step at the very end. He is very important and very often forgotten. So we do this and we get 0.0128. So now we have described the sampling distribution. So we verified normality when we increased our sample size to 250. We found the mean of that distribution is going to be 0.043 because that's what the population unemployment rate was in 2007. Okay, there we go. And then we found the standard deviation of that proportion. So now we'll look at calculating some probabilities, and I apologize, I did not give you nearly enough room for this. So the Texas Workforce Commission reported the state unemployment rate was 4.3% in March 2007. Find the probability that a sample of 117 people will have a sample proportion of more than 9%. Well, we know it's not going to be normally distributed with 117 people, so let's go ahead and change that to 250. Okay, and part B also has 117. We're going to go ahead and change that to 250 right now. Because as we saw, a sample of only 117 people did not give us a normal distribution, meaning a bell-shaped distribution. And it has to be bell-shaped for us to calculate probability. So now we're going to follow our 4 steps. So step 1 is to calculate our z-score. So z equals, I don't have room to rewrite the formula, so I'm just going to go back up to it real quick. P hat minus P divided by the square root of that standard deviation. So we found P and we have the standard deviation. We found those in this problem because all of our values are the same. But we need to find, oh, here we go. Our P was given to us, 9%. So that's our P hat. This guy right here is P hat. So we're going to take 9% as a decimal, 0.09 minus 0.043. We're going to divide that by 0.0128. So go ahead and do that. 0.09 minus 0.043, 8, and you get 3.6719. So now we can go on to steps 2 and 3. Draw your bell curve. Okay, the mean is still 0. Go ahead and put that line. And then we need to label our z-score so that he's going to be way up here. And then we want to know the probability of it being more than that. So we're going to shade everything above our z-score, 6719. And then finally, step 4, because this is normally distributed, we verified that in the previous example, we're going to use normal CDF, 3.6719, 1,000,000, 1. And I have to recalculate this real quickly. Give me just 1 second. Let me see, that's the one I want. It moves so slow sometimes. Okay, 3.67 1 9 1,000,001, and we get 1.2, but then there's an e to the negative 4, so that is 0.0001. So a very small probability of having more than 9% of people say they are unemployed if you sample 250 people. So find the 99th percentile, find the 99th percentile of sample proportions for n equals, and we change that to 250. So now this is one of those working backward problems. So the first thing we needed to do in one of these problems was to draw our curve. So draw the curve and then shade the appropriate region. So a percentile means the probability or the percentage less than the value. So that means, so 99th percentile means I'm going to color in, I'm going to shade 99% of my graph. So almost all of it. I'm going to stop right there. So I've shaded in almost everything. And then right here is an unknown z-score that I need to go find. So to find that unknown z-score, I'm going to use the inverse norm. That's step 2. Inverse norm. Remember, inverse norm, the first thing it wants is the area less than your unknown z-score. So in our case, that's 0.99. And then it's always 0, 1. When we do that, we get 2.3263. Okay, and then I'm missing a step in here somewhere because I had 4, but now I only have 3. I think this was actually 2 steps. This is step 2, and this is step 3. Is that correct? I don't remember my own steps. That's fine. And then the last step is to solve for p hat. So p hat is going to be equal to your z-score times the standard deviation of p hat plus the mean of p hat. So our z-score is 2.3263 times 0.0128 plus 0.043, and that's going to give us p hat. So we're going to calculate that. 2.3263 times 0.0128 plus 0.043 is 0.0728. So 99% of samples will have an unemployment rate of 7.28 or less. That's what this is that we just found. So I'll say that one more time because I don't have room to write it on here. 99% of our samples will have an unemployment rate of 7.28% or less. That is what we found. So that's it for this section. Just to recap, the biggest things to get out of this one are these 4 things right here. So how to check and make sure that you have a normal distribution. Okay, if you don't do these first 2 equations, this n times p and this n times 1 minus p, if you don't do these 2 guys, you cannot say that you have a normal distribution. And you must do both, and they both must be greater than or equal to 10. Okay, and then the mean, the standard deviation, and the z-score equation for proportions. And just remember that all of these values are p, except for in the z-score equation is where we finally see p hat, where p hat is for the sample, and p is the proportion for the population. So that concludes Module 12, and that's it.